Here we have a problem on integration. So that is, we have to integrate the function natural logarithm of x over x with respect to x. Okay, I'm going to use the method of substitution to evaluate this integral. Okay, here as soon as I said method of substitution, you may have a question. So as soon as I see this integral, how can I decide that I have to use method of substitution in this particular problem? Okay, let me explain you integral. So I'm going to write the given function ln x over x as ln x times 1 over x times dx. Here, the function is the stuff that we have between the integral sign and dx. That means ln x times 1 over x here. Okay, here natural logarithm of x is a part of the function. What is its derivative? Its derivative is just 1 over x. So the derivative of this natural logarithm of x is 1 over x. So that is in the function itself, and we are able to write this 1 over x along with dx using multiplication. Already they are multiplied. Okay, so in a function, the derivative of a part of the function is in the function itself, and we are able to write the derivative along with dx using multiplication. Then we can use method of substitution to integrate the given function. So that's the idea, to decide that I have to use method of substitution in this problem. So the derivative of natural logarithm of x is just 1 over x. It's in the function itself, and it is multiplied by dx. Okay, now what is the next part, method of substitution? So we just have to assign, we have to substitute a new variable. So for the part for which we have the derivative, actually we have a derivative for the part ln x. So for this ln x, now I have to substitute a new variable. That's why this method is called method of substitution. So now I'm going to assign a new variable t for this natural logarithm of x, ln x. Okay, once I substitute a new variable for a particular part of the function, the complete integration has to be changed to the new variable t. So here we have this integration with respect to x. That's why we have dx over here. When I change the complete integration to the new variable t, I must have dt, because the integration has to be done with respect to t. Okay, here we have dx, but instead of dx, if I want to get dt, what should I do with this t? So I have to find the derivative. Only if I find the derivative of this t, it will become dt. Okay, now on both sides of this equation, I'm going to find derivative with respect to x. So the derivative of t with respect to x is dt over dx. And the derivative of natural logarithm of x with respect to x is just 1 over x. Okay, now let's multiply both sides by dx, because x dx must be together. So the dx will cancel out. I get dt equals to 1 over x times dx. Okay, so now what I'm going to do is I'm going to plug in the given integration. For ln x, I can plug in t, because that's what we have assumed, t times, and for this 1 over x times dx, I can plug in dt. So t times dt. Okay, now it's a very simple integration. That is, we have to integrate the variable t with respect to t. And what is the exponent of this t? There is no exponent for t. We have to assume there is 1. And here to integrate this this one, to evaluate this integration, we can use the power rule of integration. That is, integral x to the nth power dx means we have to add 1 to the exponent and divide the result by the same exponent, n positive 1 positive c. The same thing we have to do over here. That is, we have to add 1 to this exponent 1, then it will become 1 positive 1, and divide by the same exponent 1 positive 1 positive c, and t square over 1 positive 1 is 2 positive c. Actually, t is a variable was taken by us. It has to be replaced by the original stuff. We know that t equals to ln x. So now we can replace t by ln x. So in that case, I'll be getting ln x the whole square. Actually, for t, I plug in ln x. Since we have square for t, the same square we have to take for ln x over 2 positive c. So the evaluation of the given integral is ln x whole square over 2 positive c.